Okay, so today, as I said, we're going to look at the mixture problems again, just as a review, but we're going to take a little bit different look than what most of the questions in the book did. Most of the questions in the book took the simplified route of giving you the amount of one of the ingredients. In real life, you're more likely to know what the finished product needs to be. For example, let's say we need 400 milliliters of a 33% solution. We have 32% and 36% solutions. And we need to figure out how much of each do we need to get that 400 milliliters of 33%. There are two different ways we could approach this. The first one, of course, was just to list out our ingredients here. 32% and 36% are going to combine to make that 33%. And then define the amounts. We know that we're going to have 400 milliliters of the 33%. We don't know either of the amounts for the 32 or the 36. We could use two variables, x and y, or whatever we wanted to use for those variables, and do a system of equations. Or we could save ourselves a step or two and write it as a single equation. I usually let the amount of the higher concentration, in this case the 36%, be my variable. X, Y, whatever you want to use. So we're going to let the amount of the 36% be X. Now we could make the amount of the 32% Y, but in order to avoid a system of equations, we're going to do this. If the total has to add up to 400 milliliters, and we have X amount of 36%, then the 32% has to be 400 minus X. And we can write our equation from there. So now the amount of 32%, or the amount of medication in the 32% solution, is our concentration, which is the decimal form of the percent, so 0.32, times the amount, which was the 400 minus X. Plus 36%, 0.36, times that amount, which is X, has to equal the amount of medication in the final product, 33%, 0.33, times 400 milliliters. And now we can do some simplifying. So we have 0.32 times 400, which is going to give us, I believe, 128. 0.32 times negative x is a negative 0.32x. Then we still have the positive 0.36x here. And over here it's 0.33 times 400 is 132. Now we can go about combining whatever we can in this equation. We have a negative 0.32 and a positive 0.36, which is a positive 0.04x. So we still have the 128, and that still equals 132. Now, solving for x. We need to get rid of the 128, so we're going to subtract 128. So 0.04x equals 4. Now we divide by 0.04. So x equals 100. So now going back, first thing we need to find is what does x represent? X represents the amount of the 36%. That's 100. To find the units, we look right here. This was in milliliters. This better be in milliliters. So now this one was 400 minus x. 400 minus 100 is 300 milliliters. So there we go. Now another classic problem, we went over this one a little bit last week as well, is we have an amount of a certain solution. And we need to remove some of that solution and add whatever required amount of either neutral solution or pure medication to change its current level. So let's say we have an 800 milliliter bag for an IV. of 67% solution. So we need that full bag, but we need it to be, oh, what do I put in here? I already used a really bad number, so let's just keep going. Now let's say we need that to be 78%. So how do we make this work out? In other words, how much do we need to drain from the bag and add pure medication? Now remember, the serum was the word we were using for pure medication. So how much pure serum do we need to add to this? So again, what we have here is we have an ingredient of 67%. To that, we're going to add pure medication. Now, pure medication is pure means 100%. And we need to get a result of 78%. And now, at first, it doesn't look like we have the amount that we need. But remember, it's an 800 milliliter bag. And we're going to drain some out and replace it with the pure medication. When we are done, we will still have 800 milliliters. We're going to let the amount that we drain out. Now, the amount that we drain out and the amount of pure serum we put back in is going to be the same. So we're going to let X represent both of those, the amount of pure serum and the amount that we'll have to drain out to make room. So that means the 67% is going to be 800 minus X. And we'll go through our same process. So 0.67 for the 67% times 800 minus X plus 100% is just 1X equals 0.78 for 78% times 800. So we need a little help here. 0.67 times 800. 536. 0.67 times negative X is a negative 0.67X. Plus 1X equals 0.78 times 800. 624. So now we have negative 0.67 plus X is 0.33X. That's a positive. We have the 536 here yet. Equals 624. We'll subtract 536. 0.33X equals, is that 88? And now we'll divide by 0.33. So X equals 88 divided by 0.33 is going to be 266.67. So 266 and 2/3 milliliters. They need to be drained out and added back in. Okay, well, enough of those. Like I said, those are the more complex form of the mixture problems that go a step beyond what the book chooses to do. The book chooses to give you the easy one and always give you the amount of one of the ingredients instead of give the total amount. But in real life, generally, it's the total amount of that particular resulting solution that you want. Let's take a look at a related problem that solved the same way, but not necessarily a medical solution. Let's look at an investment problem. And in this situation, let's say you have two investments. And let's say our investments, we're going to earn 4% on one and 8% on the other. And you have $5,000 to invest. At the end of 1 year, you have earned a total of, oh, let's see here, $275 we're going to go with. So here's the question. How much was in each investment? This problem looks way different than our solutions problem, but it's exactly the same. We're basically mixing our investment percents. We're mixing a 4% with an 8% to get a result that is an unknown percent. But that's okay because we have the actual amount of the resultant. Over here, we don't know how much was invested, so we'll let X be the amount invested in the 8%. Again, I always let X be the amount for the larger percent because that avoids having to work with negative numbers later on. If, of course, we know that 5,000 was the total amount invested in both of them combined, so if X was the amount of the 8%, then the 4,000 or 4% was 5,000 minus X. So we have the amount of return from the 4% investment would be 0.04, 4%, times 5,000 minus X, plus 8% investment would be 0.08 times X. And that's going to equal, now normally here we would do a percent times the amount, but we don't know the percent. But if we look at the problem closely, we are given what that total return was. It's the $275. So it saves us a step there. Now 0.04 times 5,000 is 200. 0.04 times negative X is a negative 0.04X plus 0.08X equals our $275. Now here's where you can see, I mentioned that I let X be the larger percent so that we didn't end up with negative numbers down here. And here's where you can see that coming into effect. I have a negative 0.04, that's a negative 4%, a positive 0.08, a positive for the 8%, which comes out to be a positive 0.04X. Had I switched that around, that'd be negative, and I'd end up dividing by a negative later. Which isn't the end of the world, it just saves a couple potential mistakes. So now we're solving this. 200 plus 0.04x equals 275. And as always, we're going to subtract the 200. So 0.04x equals 75. And we're going to divide by 0.04. So x equals 75 divided by 0.04. $1,875. So now again, here's where it was important to label everything from the beginning because we have to go out and figure out what X stood for. And our labeling up here, X was the 8%. So that tells us $1,875 was invested in the investment that got 8%. 5,000 minus X, which is going to be $3,125, went in the 4% investment. Well, let's look at a slightly different problem. Let's say we have two investments. Give a combined yield of, what do I put here? Let's go off 6%. If $2,000 was invested at 4%, and a total of, what do I put in here? $3,000 was invested. What was the return, the percent in other words, on the second investment? So now we're looking at this one a little bit differently. We have a 4% investment. To that, we are adding an unknown return, and we're getting a mixture that yields 6% total. We know $2,000 was invested at 4%. There was a total of $3,000 invested. That would be with the 6%. We don't know the amount that was invested in our mystery investment here, but we can figure it out real quickly because we have a total of $3,000. Take away the $2,000. There's $1,000 left over. So now we can go ahead and create our equation. So now we have 4%, 0.04 times 2,000, plus an unknown percent. That's going to be x. So x times 1,000 equals 6%, 0.06 times 3,000. So now 0.04 times 2,000 is $80. Plus 1,000x equals 0.06 times 3,000 is $180. So now from here we go to solve. We're going to subtract 80. We get 1,000x equals 100. And we divide by 1,000. X equals 0.1. Now, obviously, that's the rate of our answer. We need to convert that back into a percent, which would be 10%. So the second investment had to return 10% in order to get up to a total of 6% yield. Let's see, let's do one more of those. Let's say that we have $20,000 to invest. We need to average a 7% return. And what we have available, we have investments that are predicted to give 3% return and 9%. Oops, let me adjust that a little bit. Let's do 3% return and 8% return. So how much do we put in each? So here we have 3% and 8%, hoping to get a 7% total. We know $20,000 is going into the 7%, but we don't know either of the others. So just like with our solutions, I'm going to let X be the amount of the more concentrated, in this case, the higher percent yield. So the amount of the 3% will be our total of 20,000 minus X. From there, 0.03 is our concentration for 3%, or a rate for 3%, I should say now, times 20,000 minus X, plus 8% is a rate of 0.08 times X equals 0.07 times 20,000. So now, 0.03 times 20,000 is 600. 0.03 times X, or negative X, I should say, is a negative 0.03X. Plus 0.08X equals 0.07 times 20,000 is, let me double check that. Should be 1,400, but I'm double checking myself. Yes, it is. Okay, so from here, we're going to combine The negative 0.03 and the positive 0.08 is 0.05x. That's positive, so I'll put a plus there. 600 stays, and it still equals 1,400. Now we're going to subtract 600. 0.05x equals 800. And we'll divide by 0.05. X equals 16,000. Now again, we have to make sure we're careful to go back and answer the questions. Question was how much in each? So X is 16,000. That is the amount of the 8%. 20,000 minus X, so 20 minus 16 is 4,000. Would go in the 3%. Okay, now this next example I'm going to show you is quite a bit more complicated. We've talked about how you can use systems of equations for solving these. We avoided it by just doing this. Technically, what that step there, 20,000 minus X, what we were doing was saying that X plus Y equals 20,000. But then we were using a substitution where we replaced that, we solve for Y by subtracting X. To get that Y is just equal to 20,000 minus X. Then we plug that in there instead of having a second variable of Y. Well, this next example we're going to look at is still a mixture problem, but it's a little bit more complex. When you get into mixing materials, alloys, you're looking at different metals being put together or different materials being put together in solutions. And most often the two materials that are put together have different thermal properties, different melting points and stuff like that. So what we're going to look at here is we're going to look at having an alloy, which is a mixture of the two metals. And we're going to look at how, as we heat them up, how they separate. Because, like I said, as the two materials have different thermal properties, different melting points and boiling points and stuff like that, here we're just looking at the melting point going from solid to liquid. You would think when you mix them together, you get a mixture of those. Unfortunately, it doesn't. It actually separates into some strange characteristics. Let me get a line up here, and then we'll go from there. So let's say that we have a material that is 40% nickel and 60% copper. So that would be right here. I'm going to alter that a little bit so you can see it better. So there it is. That little line is at 40%. And let's say that we have let's go with just 400 grams of that material. What you can see here, this point here, below that temperature, this is all solid. This temperature here, above it, it's all liquid. Between there, it creates kind of a mush. And unfortunately, it's not a straight mush. It separates into different compositions of that material. For example, let me do this. I'm going to copy my line. Let's say it's at 1250 degrees. At 1250 degrees, this separates into this material right here, this concentration, and this concentration. This part here is solid. What it'll be is it'll be a mush, is I'll have liquid with solid chunks floating around. Well, the liquid part is going to be this composition right here. Let me move a line over there to represent that. So at that point right there, I'm going to change its color. So that is going to be liquid. This part over here are going to be the solid chunks, and those are going to have a much lower nickel content. As you see down here, what we have is the liquid chunks. If I can get back to that pen. The liquid chunks Right here, they look to be about 43% nickel, which would make them, of course, 57% copper. The solid parts, right here, they look to be only about 30% nickel, which would make them 70% copper. Well, we started out with 400 grams of 40% nickel and 60% copper. So that means we started out with 400 times 0.4, or 160 grams of nickel. 400 times 0.6, or 240 grams of copper. Those must stay the same. We want to know how much of this mixture at 1250 degrees, which is the temperature we chose right here, how much of it is going to be liquid and how much of it is going to be solid. So we'll let X equal the amount of liquid. That is going to be the 4357. And Y be the amount of solid, which will be the 3070. And what we'll find is the amount of we're going to set up two equations. One equation is going to be for the amount of nickel. So the amount of nickel, come on. Oops, my Word doc. Here we go. Our nickel equation is going to be 0.43. Said X was the amount of nickel. Oops, the amount of liquid. Okay. So in the liquid we have 43% nickel. So we have 0.43 X, that's the amount of nickel in the liquid, plus 0.3 Y, which is 30%, that's the amount of nickel in the solid, has to equal the total amount of nickel, which is 160 grams. Our second equation describes the copper. Well, 57% of the liquid, which is X, is copper, plus 70% of the solid, which is Y, is copper, and we need a total of 240 grams of that. So here we have a pure system of equations. Now, many people that I encounter, the reason I wanted to do this example, they're so used to seeing a system of equations where you're going to multiply one equation or both equations to get the coefficients the same. Sometimes you run into one like this where multiplying is kind of difficult to do. It's actually easier to divide. So what I'm going to do is I'm going to divide this top equation by 0.3. That'll make this a 1y. I'm going to divide the bottom equation by 0.7, which will make this a 1y. So what I'm actually going to do is I'm going to divide the bottom equation by a negative 0.7. So that'll cancel out when I do my addition method or elimination method. So 0.43 divided by 0.3. 1.43 X plus, of course, 0.3 divided by 0.3 is 1. Y equals 160 divided by 0.3. 533.33. Down on bottom, 0.57 divided by 0.7. Actually, a negative 0.7 will give me negative 0.81. Negative 0.81 X. Get a negative 1Y. 240 divided by negative 0.7. Give me negative 342.86. This was supposed to be 533.33, not 53. Let me get extra. There we go. And now we're going to combine. We're going to use elimination or addition. We're just going to add right down the columns. So 1.43x plus a negative 0.81 is 0.62x. Positive y and negative y cancel out. 533.33 plus a negative 342. 533.33. I'm just going to subtract 342.86. 190.47. And now I can solve this by dividing by 0.62. X equals 307.21, we'll call it. And that is grams. Remember, X represented the amount of the liquid. So we have 307.21 grams of liquid. Out of our total of 400 grams, then we're going to subtract, that makes 92.79 grams of solid. So there'll be 92 points, almost 93 grams of solid chunks floating around in there. And remember, this is going to be 43% nickel and 57% copper. This here would be 30% nickel and 70% copper. This is actually one method that is used if you have an alloy and you need to separate it, change the concentration of the alloy. And actually just use these charts to heat it up and separate it like that. Like I said, this is something beyond what we're doing in this course, but it's actually a very good example of the mixture problems. One where we can't cheat and get away from the systems of equations. This will not be on a test or quiz or anything like that ever, just so you know. But it's a little bit of enrichment for those of you that, since we have two schools that weren't, or one school that isn't in today. Just so you guys know, tomorrow, Wednesday, we're going to continue on with new material. Friday, all of you are gone, so Friday I'll actually cancel the session so they don't put up the network. With that, there is no new homework today. I'll let you out of here 10 minutes early. You guys have a great day, and we'll see you on Wednesday.